Before I start this video, I want to ask you to support me by subscribing to my channel. And please like this video if you find it helpful. And of course, if you have some questions or suggestions, welcome to the comments. And we jump right in.
Hi everyone! Today there will be a quite interesting video in which I will demonstrate the creation of a microservice using the Symfony framework for sending email in domain-driven design or DDD style. Let's start with the theory. If you want to skip the theoretical part, then I will make the navigation for this video so that it is easier for you to skip. So, why I decide to choose domain-driven design to create my microservice? First, focus on business domain. DDD places a strong emphasis on understanding and modeling the core business domain. This aligns well with microservices, as each microservice is intended to represent a specific business capability or domain. By dividing the system based on business domains, you can achieve better separation of concerns and clearer boundaries between microservices. Second, bounded contacts. DDD introduces the concept of bounded contacts, which allows you to define clear boundaries around different parts of your application. In a microservices architecture, each microservice represents a bounded contacts. This isolation helps maintain autonomy, scalability, and independent development and deployment of microservices. Third, aggregates and entities. DDD encourages defining aggregates and entities, which are fundamental building blocks in modeling the domain. In a microservice context, each microservice can encapsulate its aggregates and entities, ensuring better encapsulation and reducing the risk of leaking intimal details to other services. Fourth, ubiquitous language. DDD promotes the use of shared language, ubiquitous language, between domain experts and developers. In a microservice environment, each microservice team can communicate using its ubiquitous language, which facilitates better communication and understanding of the business requirements and models. Fifth, independent deployment and scaling. Microservices benefit from being independently deployable and scalable. DDD's focus on bounded contacts and modular design helps achieve this independence, allowing you to scale and update specific microservice without affecting the entire system. 6. Domain events. DDD introduces the concept of domain events, which are available for maintaining consistency and data synchronization between microservices. When something significant happens within a microservice, it can publish domain events that other services can subscribe to and react accordingly. 7th, clear separation of concerns. DDD helps establish clear separation between the business domain logic and infrastructure concerns. This enables microservices to focus solely on the business domain, making them easier to understand, test, and maintain. 8th, decentralized data management. In DDD, each microservice has its data store, which contributes to the decentralization of data management. Each microservice owns its data and is responsible for its persistence, reducing the complexity of data synchronization and ensuring loose coupling between services. In conclusion, domain-driven design complements the principle of microservices, providing a systematic approach for modeling complex business domains, clear boundaries between services, and a shared understanding between domain experts and development teams. When properly applied, DDD can lead to a more maintainable, scalable, and resilient microservice architecture. In the context of domain-driven design, a layered and clean architecture is employed for building the application. Let's delve into what this means. The layered architecture approach involves breaking down the application into distinct layers with clear responsibilities. Each layer is responsible for specific aspects of functionality and only interacts with adjacent layers. The clean architecture approach aims to divide code into layers with a clear dependency flow, originating solely from internal layers to external ones. The main goal is to maintain the independence of business logic from implementation details and external frameworks. In DDD, this is manifested through the separation of layers and the application of the principles of dependency inversion. The entire structure is built around a clear separation of responsibilities, facilitating easier testing, modification, and scalability of the application. It also enables the introduction of new technologies or changes to the implementation details without significantly impacting other components. Now let's lay down the basic folder structure, and I will explain what and where will be stored. As the tutorial progresses, we will delve deeper into this topic. Application. This folder contains application-specific code, which focuses on coordinating the interaction between the external world, UI and infrastructure, and the domain layer. It includes use cases and commands that represent the application's high-level business logic. Use case. This subfolder contains different use cases, each representing a specific interaction or user operation within the application. A use case typically corresponds to a single action that users can perform, such as creating a mail, sending a message, and so on. Command. This subfolder is dedicated to command-based use cases. Commands represent actions that users or external systems request to be executed. Mail. Within this subfolder, we focus on use cases related to mail operations. Create. The subfolder is specific to the create mail command use case, which deals with creating new mail. Domain. The domain layer is the heart of application, representing the core business logic. It is designed to be independent of the user's interfaces and infrastructure, allowing the domain to be the most critical and reusable part of the application. Entity. In this subfolder, we define domain entities, which are the main business object in the application. Entities encapsulate both behavior and state, representing the core concepts of the domain. Repository. This subfolder contains interfaces that define domain repositories. Repositories provide an abstraction layer for data access and allow the domain layer to work with persistent data without being tied to a specific data source implementation. Service. Within this subfolder, we implement domain services, which encapsulate domain-specific business logic that doesn't naturally belong to any specific entity. Services can be used by multiple entities and help keep domain entities focused on their core responsibilities. Infrastructure. This folder houses infrastructure-related code that implements the technical aspects of the application, such as database access, external service integration, and so on. Persistence. Inside this subfolder, we handle persistent-related code. Doctrine. Here we provide Doctrine implementations of domain repositories. These implementations enable interaction between the domain entities and the underlying database using the Doctrine ORM. UI. This folder contains the user interface code for the application, responsible for handling user interactions and translating them into use cases in the application layer. HTTP. Within this subfolder, we handle the HTTP-related user interfaces, which include REST, API, and web interface controllers. REST. This subfolder contains controllers for the REST API endpoints. The controllers receive incoming HTTP requests, extract the necessary data, and delegate the processing to the application layer, executing the appropriate use cases. Web. This subfolder is dedicated to controllers for the web interface. These controllers handle incoming HTTP requests specific to the web application and interact with the application layer accordingly. In the presented structure, the groundwork for queue-based processing is pre-established, setting the stage for efficient asynchronous operations. However, the actual implementation of queues will be deferred until later stages of development. Initially, the focus will be on building and refining the core business logic, ensuring a robust foundation before integrating queue mechanism for enhanced performance and scalability. Now let's create and set up a project and then set up a folder structure. There will be no explanation at this stage, since I have the corresponding videos on my channel. Pay attention to pop-up links. If you have some questions, write in the comments. So, let's go! Okay, let's get started with the implementation of the logic of our microservice. In general, it is assumed that the user will be able to send a letter to the company from the page of our website. And also, after sending the letter, an email notification will be sent to the mail address specified by the user with the message that the appeal has been registered. But in the context of this video, we will not implement the user interface. We will send requests through Postman. So, let's go. And we will start by redefining the path to the controllers folder in the rows configuration file and specifying the appropriate namespace. This is necessary because now our controllers will be stored on the UI layer. The data that the user inputs in the form fields will be saved in our database. This will provide a lot of advantages. For example, if the user submits the form but the server crashes, we will be able to recover the data from the database and send it later. Therefore, now we will install the ORM pack for Doctrine support and the Maker bundle so that we can create an entity using the terminal. And then we will set up the database. Now let's create an entity that's necessary for manipulating the relevant data within the context of our task. Actually, users will fill out something like this form. This will help you figure out what properties the entity should contain.
And now we need to set up an actual path for the entity. To do this, we need a Doctrine.yml configuration file. Let's update database schema. And also let's back to our repository file and add saved method there. Okay, we will send emails with Symfony Mailer Bundle. So, Mailer Bundle is a component in the Symfony framework that provides email sending capabilities. It allows developers to easily send emails using various transport methods such as SMTP or third-party services like Amazon's SES. The bundle simplifies the process of creating and sending emails, making it efficient and straightforward for developers to incorporate email functionality into their Symfony applications. We will use built-in transports, specifically utilizing an SMTP server to send emails. Additionally, we will use a third-party transport, namely Amazon SES, and we will use in Gmail as the email account for sending and receiving emails. The first thing we need to do is to install the Mailer bundle using the following command. After installing the bundle, we need to configure the transport through which emails will be delivered. In Symfony, we can efficiently deliver emails over SMTP by configuring the DSN in our env file. And for this demonstration, we will utilize Gmail's SMTP server to send our emails. Here we enter the email address through which the letters will be sent. In our case, this is assis.upay@gmail.com. Next, we must enter a password, but we cannot use the mail password directly. We need to get up passwords in the Google account itself.
and I'll show how to do it. So, go to your Google account management page. Okay, and find the Security tab. Please note that two-step verification must be enabled. So, go to the appropriate tab and scroll to the very bottom of the page. Here we need App Passwords tab. After you have generated the password, you need to copy it and paste it into env local file for Gmail SMTP authentication. We also indicate the address of the Gmail SMTP server. This is smtp.gmail.com. We also indicate the port through which the connection to the SMTP server will be made. This is port 587. The use of TLS for SMTP connection on port 587, the recommended security standard for sending emails through external mail servers. Port 587 provides a stable connection with the server and encrypted data transmission, which prevents the possibility of interception and reading of sensitive data, such as email credentials and passwords. After configuring the env local file, you can proceed directly to implementing the email sending logic. In DDD, services are created on the domain level. Actually, feedback email is an instance of feedback email which represents an entity stored in the database. Here we create an email object. Here we set address who sent this email. Here we set the recipient address. Here we set the reply to address. Since the feedback email object represents a database entity, we use its method. For example, get email address, get email topic, get email body, get first name, get last name, to retrieve the data that was saved along with the entity before calling this function. We set the topic of the email accordingly here. This is the email body set in HTML format. This line of code is what actually sends the email. And also here we use try catch construction to check was email sent or not. Let's create a factory that will create a new instance of an entity and populate it with data from the request. Now let's create a controller that will accept a POST request, which will initialize the factory, create a database record, and send an email filled with data that was previously saved in the database. The only thing left to do is to quickly configure Postman and test if the email sending is working. Let's set up email sending through Amazon SES now. Amazon Simple Email Service, or SES, is a cloud-based email service from Amazon Web Services. SES allows you to send and receive emails from any application or website. SES is a scalable and reliable solution that can handle large volumes of email. To use a third-party transport, you need to install the corresponding library. For example, to use Amazon SES, run the command. For a third-party transport, you need to add environment variables to the env local file with the data required for the transport to work. Before we can access SMTP, we need to go over a few things about this service. If you are just starting to use Amazon SES, your account will be in a sandbox environment. In a sandbox environment, you can use all of the features offered by Amazon SES, but you will be subject to certain sending limits and restrictions. These restrictions are designed to protect Amazon SES from spam and other abuse. Here are some restrictions that apply to Amazon SES in a sandbox environment. First, the maximum number of messages you can send in 24 hours is 200. Second, the maximum sending rate is 1 message per second. And third, you can only send messages to addresses that have been verified as part of domain verification process. If you want to increase your sending limits, you can apply to leave the sandbox environment. To apply to leave the sandbox environment, you must verify your domain and provide relevant information about your company. However, we are not interested in production access yet, so we will be working within the sandbox environment. Therefore, before we get the credentials, let's confirm our email address with which we are working in the context of this lesson.
Now let's get SMTP credentials. Please note that SMTP credentials can only be viewed or downloaded once. They cannot be recovered, but new credentials can be created at any time. Now let's fill mailer DSN with our current SMTP credentials. Here you can see that the email was sent via Amazon. Symfony's mailer support high availability by using a technique called failover. This means that if one mailer server fails, the mailer will try to send the email using another mailer server. The failover transport is configured with 2 or more transports and the failover keyword. I'll show it. The failover transport will start using the first transport, which is Amazon SES in this case. If it fails, the failover transport will try to send the email using built-in SMTP transport. If it also fails, the failover transport will give up and the email will not be sent. Let's reproduce the behavior in which the first transport does not work. Therefore, in response to the email sent by the user, we will send a confirmation letter to the email specified by user that our support will deal with his issue as soon as possible. If we use Amazon SES as the first transport, then sending through it will fail, because our account is in the sandbox and the user's email is not verified. Therefore, sending will have to occur through the built-in SMTP transport. Let's quickly implement this logic and test it.
Let's check how it works. As you can see, the user received a confirmation and it was not sent through Amazon. Also, Symfony's mailer supports load balancing via a technique called round robin. This means that the mailer will send each email to a different transport in a round robin fashion. This helps to distribute and load evenly across the transport and prevents any one transport from becoming overloaded. The round-robin transport is configured with 2 or more transports and the round-robin keyword. I'll show it. The round-robin transport will start by sending the first email using first defined transport. The second email will be sent with second defined transport, and so on. This process will continue until all of the emails have been sent. If one of the transport fails, the round-robin transport will simply skip the transport and move on to the next one. This ensures that email will still be sent even if one of the transports is unavailable. The round-robin transport is simply an effective way to load balance emails. It is a good choice for applications that send a large number of emails or that need to ensure that emails are delivered even if one of the transports is unavailable. And for today, perhaps we will already finish. The video is going to be big. In the next video, we will organize the work of our microservice through queues. I hope this video was helpful to you. I hope you enjoy this video and see you next time.